so today we're going to continue on with these examples. So all of these are word problems, be very careful with them. All right, in this first one we have a tree that is 8.5 metres high, casts a shadow that's 3 metres long. Now what happens with this is we start with the sun up the top in the sky here. One of the rays of sunlight goes from the sun and comes all the way down and hits the ground. On its way through, it will connect with the tops of different things. In this case, it's a tree. So our tree is standing there. Okay? Now, as it touches the top of that tree, which is at right angles to the ground, we assume it's vertical, it will throw a shadow, and that's how long the shadow is going to be. All right? So the shadow is here. All right, so our tree itself is 8.5 metres high, and it's casting a shadow that's 3 metres long. Now, I know this doesn't really look right, because that should be longer than that, but that's okay. We're not doing anything to scale. So the sun ray hits the top of the tree, continues to the ground, and that's actually what forms the shadow. All right, so now the question asks for the angle that the sun makes with the ground. So we have the sun rays here, the ground here, and we're looking for the angle between those. So I'm going to write a theta in there. All right, let's label our sides. This side here is our opposite side. This side here is our adjacent side. So we must be dealing with tan. So tan theta equals O over A. Tan theta equals 8.5 over 3. And now we're ready to find theta. So we're going to get rid of our tan, move it to the other side and do inverse tan. And now we go to our calculator. So you're pressing inverse tan or shift tan. Then we're doing the fraction key. We're putting 8.5 on the top of the fraction, down arrow, 3 on the bottom, right arrow and bracket. Press equals and we're up to here. All right, now it doesn't say anything, so we're going to the nearest minute. So remember, when we get our answer, we're now just going to press our degrees minutes button there. And there's our answer. Now look at the seconds. It's 35.87 seconds. That's 30 or more. So we're going to take our minutes up by 1. So the minutes will go to 34 minutes, and the answer is 70 degrees, 34 minutes. Okay, next question. So we're looking at a resort this time. The beach slopes down. After walking 8.5 metres down the slope, from the water's edge, the water has a depth of 1.6 metres. So in other words, you're standing here, the water's edge. You walk into the water down a slope, and you find yourself standing in water that is at a depth of 1.6 metres. Now you walked 8.5 metres down the slope, so that's this bit here. What are they asking for? They're asking the angle at which the beach is inclined to the horizontal. So we want the angle between the beach and the horizontal. Okay, here's the horizontal, and this is the beach sloping down. Okay, so we're looking for the angle between those. So put your theta in there. Now let's label our sides. This is our hypotenuse, and this is our opposite side. So we must be dealing with sine. Sine theta equals O over H. Put everything in, and we have sine theta equals 1.6 over 8.5. And now we're finding theta, so we're going to get rid of the sine. Come to the other side and do inverse sine. So we put this in our calculator. You can all do it yourself, and let's see what we get. So, shift sine, fraction key, 1.6 on the top, down arrow, 8.5 on the bottom, right arrow, bracket, equals. When you get your answer, you're going to your degrees, minutes, seconds button, press it, and you will end up with that. 10 degrees, 50 minutes, 59.34 seconds. Our seconds are 30 or more. So our minutes we're taking up by 1. So we're going to 51 minutes. So it's 10 degrees, 51 minutes. Okay, and our last question, number 9. So we have a pile of wheat. It's in the shape of a cone. So I've drawn it. It's not going to be a cone going the other way because it's a pile of wheat. It's sitting on the ground and it's going to be stacked like that. Okay, it has a diameter of the circle at the bottom of 35 metres. It has a slant height of 27 metres. Now the slant height of a cone is this. Okay, so we have a perpendicular height, which will be from the top to the middle of the bottom there, and it's at right angles, but that's not what they've given us. They've given us the slant height, and that's 27 metres. So we'll put that on. Now, we have to find the angle of repose, and they've explained what that is. It's the angle the sloping side makes with the base. All right, so there's your sloping side, and the whole circular base is the base. So what we do here is just look at a piece of the cross section. So I need you to get your red pen, and you're going to draw in a right angle triangle like I've done. So there is a right angle here. Okay, so we're finding the angle that the sloping side makes with the base, so it can be any line on the base. So we're just looking at the radius of the circle as our base. All right, so we're looking for, I might write it in red pen, that angle there. Okay, that's our theta. Goes from the sloping side to our radius on our base. Okay, so let's look at what we have. We do have our hypotenuse, but we don't have anything else in the right angle triangle unless you start thinking about it. I'm sure you can work out that side. That side is going to be half of 35. All right, so you can do half of 35 or 35 divided by 2, and that will give you 17.5. Okay, so that side is our adjacent side to our angle. All right, so if we've got A and H, we're using cos. So we're doing cos theta equals A over H. Now we're going to put our numbers in. So we have cos theta equals 17.5 over 27. And then we're going to find our angle, so we need to get rid of cos. Go to the other side and do shift cos or inverse cos. Make sure you've got your fraction here in brackets. And then we're going to go to our calculator for the answer. So we're pressing shift cos, fraction key, 17.5 on the top, down arrow, 27 on the bottom, right arrow, bracket, equals, press your degrees, minutes, seconds button, and you'll get that answer. So we want it to the nearest minute because they haven't said anything about nearest degree or anything. So look at our seconds, it's 52.35 seconds, that's 30 or more. So we're taking the minutes up by 1 to 36 minutes. So we have 49 degrees, 36 minutes. And that's the end of the examples today. So just do plenty of practice on this work. It's the only way you're going to get better at your trig, and you definitely need it in year 11 and 12.